So for Unit 5, first off, you could cross this out. The title is wrong. It is Unit 5, but this is statistics. I didn't catch that until after I'd made the copies. So now we're going to jump around, kind of hit the basics of as much of this as we can, skipping the longer ones. So the ones that have you do standard deviation by hand all the way out. I will try to take time to do one of those right before the final or at the end of class today if we have time. But there's at most going to be like one question like that on the test, and it takes like 10 minutes. So that's a low priority, whereas we're going to hit the ones that are like 30-second questions that are also going to show up on the test. Those, again, you can get a lot more bang for our buck here in the next 25 minutes by hitting those. So first, find a 5-number summary given the data. 5-number summary means minimum, maximum, median, Q1, Q3. First off, check, is the data in order? It is, so we're good there. We have our minimum, we have our maximum, and we got 1, 2, 3, 4, 5, 6, 7, 8 pieces of data, which means my median is in between those two. So add them together, divide by 2. 21 plus 23 is 44. 44 divided by 2 would be 22. There's our median. Now, this is my dividing line. That means there's 4 pieces of data at the bottom, which means I have to get another average. 13 plus 21 is 34. 34 divided by 2 is 17, right? You guys should double check my math there, but I'm pretty sure we get a Q1 of 17. And then up here, our Q3, halfway in between those two, is going to be 30.5. So when I draw out my 5-number summary, and I have minimum, max, median, Q1, Q3, minimum's 10, maximum was 43, median was 22, Q1 was 17, Q3 was 30.5. Does anyone have any questions about finding that 5-number summary? Now, part B is the part that I was saying we're going to skip that for now, because that's doing the entire table to find the standard deviation, right? Finding the average, doing the subtractions, squaring them all, adding them all up, dividing by how many there were. That's the variance, and then taking the square root to get standard deviation. If we have time at the end of today or before the test for you guys on Thursday, we will go over one of those questions all the way through, piece by piece. But for now, let's skip it and look at the easier pieces. So number 2, they've already made a 5-number summary for us. Part A, is there an element in the data set that must have a value of 12? How do I even check that? What do I look for? If this number of data values is odd or even, right? Because if it's odd, I have a middle value, and that's the 12. Is this odd? Yeah. So we're going to say, yes, 12 must be a value in the data set because there are an, this is the one I always start with, there are, and it really should be there is an even number, or an even number. Let's change that. There is an not even, odd number of data set items so 12 is the middle number, or the median. So again, if it's odd, if n is odd, number of numbers, then that median is an actual number. If it's even, it's an average, and therefore doesn't have to be a number in our data set. Does everybody understand how that works with this one? If you look back up here, 22, is 22 in my data set? No, I have 21 and 23. 22 is the average of those two. The reason that happened was because there was an even number here. Here, there's an odd number, so that 12 is directly in the middle. B, approximately how many elements in the data set are less than Q1? This one we did not spend a lot of time on during the actual unit. So I'm just going to make sure everybody understands. A box and whisker plot divides our data into 4 sections with 5 points. If I have my 5 points, my box, whisker, each of those 4 sections is 25% of my data. 25%, 25%, 25%, 25%. So when they ask me approximately how many elements in the data set are less than Q1, what percent is less than Q1? 25%. So I just need to find 25% of the total number of data points. So 25 out of 100 equals X out of 41. Cross multiply, 25 times 41. 25 times 41 is 1,025. X times 100 is 100X. Divide by 100. And we get 10.25 equals X. But it wants approximately how many data items or data pieces. How many elements in the data are less than Q1. I'm not going to put 10.25. I'm going to put about 10. Right? That last one gets cut off. I just want the 10 data items, which is, again, about a quarter, about 25% of the data. It's the same thing as what we were doing with the normal distribution, but just with the 25% chunks of the box and whisker plot. So then approximately how many elements are greater than 14? Well, that means greater than Q3. Greater than Q3 is also 25%. Do I need to do the math again, or am I going to get the exact same answer? Exact same answer, about 10. Now here's what we spent the most time on for this section, or this section of the unit. Are there any outliers? Provide mathematical proof. That means find the IQR, Q3 minus Q1, 14 minus 10, which is 4. That's my IQR. Yes? Like Q1. Does that make sense? Literally, the IQR is Q3 minus Q1. Oh, you mean for this one? Let me come back to that in just a minute. Oh, sorry. Well, wait. You're good with B? Yeah. Okay, so C asks for what? Above 14? That's this piece. That's 25% again. So I didn't even recalculate it because 25% less, 25% more should be the same value. Does that make sense? So we found it for part B. Part C is the exact same thing. Does that make sense? All right. So now that we've got the IQR down here, I need to find my lower boundary, which is Q1 minus 1.5 times the IQR. Now, again, I was disappointed with how many people did order of operations wrong on the test. We need to do the multiplication first, then the subtraction. So that means here, Q1 is 10 minus 1.5 times 4. If someone works this out and they get a lower boundary of, what would that be, like 30 something, is that 30 something even reasonable for my data set? Right, that's way above everything that I have so far. What happened was they probably did 10 minus 1.5 times 4. Does that make sense? They did this first, then the multiplication. Whereas what should happen is the multiplication first. 1.5 times 4 is 6. And 10 minus 6 is 4. That makes a whole lot more sense for our lower boundary. Upper boundary is Q3 plus 1.5 times the IQR, or 14 plus 1.5 times 4. 14 plus 6 is 20. Do I have any outliers? Right. Is there a number less than 4? Yeah. So we have at least one outlier. The 2 is an outlier because it's less than 4. We don't have anything bigger than 20. So we're going to say, yes, there is an outlier. 2 is an outlier because it is less than the lower boundary of 4. Is everybody good with that? All right, letter E. Looking back at part A, if n was 42 instead, would 12 still be a part of our data set? Would it have to be? Why would they even ask this question? Like, what is it getting at? Anybody think they can explain?
Just to make sure.
They want to make sure that you didn't just, again, on part A, get a lucky guess. So what did they change, though? Right? And does that change our answer? Yes, it does, because this is even. Does that make sense to everybody? So you're going to say, would that be still an element with a value of 12? No, because 12 would be the average of two numbers. Average of two numbers. Since there was an even number of data values. Number 3 we're not going to do right now because it's the same work we were just doing here, just drawing the box and whisker plot. I would like you to try number 3 as homework though. I think you can all handle number 3. Number 4, find the standard deviation given different pieces of information. So letter A, they're giving us the total of the big chart, the big table of filling in values. They get that whole n piece. The sum of the differences squared is 84. Once you have that, you divide by the number of terms. 84 divided by 7, I believe that's 12. Yep, 12, that's your variance. If I want the standard deviation, I take the square root. The square root of 12 is about 3.464. That would be my standard deviation for number 4. Here, they're giving us variance. For part B, all you have to do is take the square root. Square root of 16, that's the square root of the variance, is 4. That's your standard deviation. Yes?
Would it be plus or minus 4?
So, since the standard deviation is a distance, usually the standard deviation itself is positive, but then we count up and down with that. Does that make sense?
Yeah.
We go above and below, but we always talk about the standard deviation as being positive. Letter C, and you'll see like that comes up in this one too. They've labeled this chart for us. That 39 is the mean, the average. So this distance is the standard deviation. So what is it? How far is it from 39 to 42? 3. We're adding and subtracting 3 for each of these. So the standard deviation is 3. And again, like what we just mentioned there, even though we're going up and down by 3s, we just say the standard deviation is 3. That's the distance that we're changing. Skip 5 for now. It's a fun question. I'll double check. I don't think it's on the test. Number 6. Average score for the history final exam was 70%. Standard deviation of 11. Draw in your little curve. This one, we need to be careful. This is a percentage, but it's the average. It's the thing we're looking at. 70, and then counting up by 11. 81, 92, 103, and then counting down, 59, 48, 37, and then we fill in the percents from the standard normal distribution, or fill in the percents from the empirical rule. 34%, 13.5%, 2.35%, 0.15%. If you get to the test and you're not sure if you remembered these right, how could you check? Oops, 0.15. Like that. If I had written 0.35 there, and I added them all up, what should they equal? 100%. If they don't add up to 100%, we've made a mistake. So here, if I add all these up, that makes 100%. What percent of students scored above 92%? Well, here's 92%. Above that is 2.35 plus 0.15, or 2.5%. What percent of students scored between 59 and 81? 59's here, 81's here. Those are the lines. The only things in between them are 34 and 34. I still have people trying to add the ones next to 59 or next to 81. Don't do that. In between 59 and 81 is just 34 plus 34, which is 68%. If 1,200 students took the final exam, how many scored between 81 and 92? Well, 81 to 92 is 13.5%. So if I do 13.5 out of 100 equals X out of the 1,200 that took the test, I cross multiply 13.5 times 1,200 equals 16,200 equals 100 times X. Divide by 100, and we get that X is 162 students. It's about 162. Letter D is the exact same thing, except you're doing below 59%. So you're adding all these up. 0.15 plus 2.35 plus 13.5 equals 16%. And then we do 16% times the 1,200. If you actually work that out, you should get 192. But again, the way you work that out is exactly the same as C. 7 is exactly the same as 6. I would recommend you try 7 on your own. 8 and 9, I want you to do as homework also. We can go over those answers real fast on Thursday. I want to do number 10 with you in our last 2 minutes. Mean test score. That's, for the Z formula, that's the mean. 75. Standard deviation is on the bottom. The student actually earns an 82. 82 minus 75 out of 2, or divided by 2. 85 sorry, 82 minus 75 gets us 7 over 2, or 3.5. Now that's a high z-score, but it's reasonable. Is 100 a reasonable z-score? Is 85 a reasonable z-score? No. Again, if you do order of operations wrong on this and you get a ridiculous answer, go back and try to figure out what happened. Your z-score should be between -4 and 4. If they are not, it's not going to work. All right.